Attempted all the questions? Hasini finished finished answering all the questions?
Yes, ma'am.
Okay. Let's see the answer for the first one. Before that, we'll recall the formulae related to circles, semicircles, and quadrants. So you check if you have recalled it correctly. All right. Area of circle. Area of circle is equal to pi r square units, correct? Pi r square units, where the value of pi, you must default take 22/7 if nothing is given, or if in the question it is specified, take pi as 3.14, then you have to take this 3.14. If nothing is mentioned, you have to take this 22/7, correct? Okay. So area of circle meaning this region. Area of this region is pi r square. Now, half of a circle is a this is actually a circular region. This one is a circular region. Now, this is a semicircular region. This is a semicircular region. Semicircular region. So, the area of a semicircle, see, in very strict mathematical language, circle is only this one. That is only the circumference is the circle. When we say circle, it is only this ring. So together with this region, the interior of the circle and the circle together is called the circular region. The interior of the circle and the circle is called the circular region. But when we say circle, we include the circular region also, meaning we consider the interior of the circle also. Am I giving you the difference clearly? When we say circle, no, it only represents this ring. But if you're talking about area, it is the area of the circle. It is strictly the area of the circular region, not circle, because circle does not have area. Circle is just a length. But we use it interchangeably. When we say area of circle, that means we are talking about the area of the circular region. Okay. Now area of the semicircular region, or which we say simply area of semicircle. Area of semicircle is equal to half the area of a circle. So half into pi r square. Please write like this only. Don't do any corrections now. Wait. If at all you have to. Half the area of a circle. Half into pi r square. Please write it like this. Don't write it as pi r square by 2. It's the same. Pi r square by 2 is the same as half into pi r square, but we'll write it like this. Half into pi r square units is the formula to find the area of a semicircular region. Next is the area of a quadrangular region. The area of a, so this is a circular region. Circular region. This is semicircular region. Semicircular region. And this is a quadrangular region. In the same quadrant, area of quadrant. Quadrant, okay. And this is all right. So area of quadrant is equal to 1/4 the area of a circle. 1/4 into pi r square units. Correct? This is right? Because it's so because see here, this is the quadrant, and it occupies 1/4 the area of the circle. Okay, it occupies 1/4 the area of the full circle. So 1/4 into pi r square. When it's a semicircle, it occupies half the area of a circle. So half into pi r square. So this is clear. All of us know this already. Pi r square, half into pi r square, 1/4 into pi r square. Okay. Now coming to the most important part where we normally tend to get confused. Perimeter. Okay, perimeter. So area is fine. Area of circle pi r square, semicircle, half into pi r square, quadrant 1/4 into pi r square. Okay. Now coming to the perimeter of the same shapes. Coming to the perimeter of the same shapes. Now, the perimeter of a circle. Okay. Perimeter of a circle. Okay. if the figure is like this, the perimeter of this one is 2 pi r units. 2 pi r units for this figure, circle. It's 2 pi r units. All right. Yeah. So here we need to be careful. Now the perimeter of when we use the word perimeter, it is only for a closed region. Okay, perimeter, the term perimeter is applied only for a closed region. Now you need to understand the length of the formula to find the length of this arc and the formula to find the perimeter of a semicircle. These are two different things. See here, this is a circle, right? This is a circle, right? Now 2 pi r is the length of the full circle. The length of the full circle is 2 pi r. So the length of half of the circle, if you cut the circle into two equal pieces, the length of each part will be 2 pi r by 2. So this is pi r units. And this one will be pi r units, correct? Pi r units. So if in the figure, you want to find the length of a semicircle, if you length of a semicircle is different from perimeter of a semicircular region. Length of a semicircle is different from perimeter of a circular region. Both are two different because perimeter is on. See, now I cannot find, or the question cannot be find the perimeter of the semicircle. Perimeter, it's not a closed figure. Then what perimeter? The term perimeter is applied to only is applied only to polygons or to any closed figure. So the length of this piece or this arc, the length of this arc or the length of the semicircle is pi r units. Pi r units. But what about this? What's the perimeter of this region? This is pi r, and here we have r and r. So the perimeter of this region, perimeter of semicircular region is equal to, there are two things. There is this one and there is this one. The length of this one is pi r. The length of this one is r plus r2r. So the perimeter of a semicircular region is pi r plus 2r units. It's not difficult because I'm stressing. We might, though we know it, we might not apply it correctly. Could you recall this from 9th standard, from 7th standard? Yeah, so here, though, now we know, but then we forget. So this thing, I don't know for what reason, but then it was difficult for children to register. It's okay. No. If you didn't recall something like this, then it's incorrect. You understand this, right? Okay. In a semicircular region, what are the two lengths you find in a semicircular region? You find this arc, right? And you find this diameter, correct? These are the two things. When you put these two things together, it's a semicircular region. So what's the length of this arc? Pi r. And what about this one? This is the diameter. So it's 2r. So both put together is the perimeter. Pi r plus 2r. Clear? Okay. Hasani, any questions?
No, ma'am.
Are you listening, Hasani?
Yes, ma'am.
Okay. Now, talking about a quadrant. Okay, quadrant. Now, this one, if you're trying to find the length of, if you're trying to find the length of this one, okay, that is, sorry, 1 second, I'll make it more neatly. Okay, you're trying to find the length of this dotted arc. Okay, if you are trying to find the length of this one alone, okay, the full length is 2 pi r. Now this dotted arc is 1/4 the length of the full thing. Okay, see when you. Okay, so if you're trying to find the length from here to here, from here to here. You want to find the length of the arc from here to here. That is 1/4. 4 arcs like this, if you put together, it makes a circular, the boundary of the circle, right? So 2 pi r by 4. 2 pi r is full length by 4. So 2 pi r by 4, 2 ones are 2 twos are, so it is 2 pi r by 4. Okay, so it is pi r by 2. Or you can come here. See, this one is pi r. Half of that, no, so it's pi r by 2. What is this one? Pi r. And half of this is pi r by 2. Pi r by 2. So this one is pi r by 2. This one is pi r by 2. This is pi r by 2. And this one is pi r by 2. All put together when you add, it's like half plus half plus half plus half. No, half plus half, 1. 1 plus 1, 2. 2 pi r. 2 pi r. So if you're trying to find the length of only this arc, it's only pi r by 2. And for this, the question will not be find the perimeter because it's not a closed figure. It's only length of the arc. But if you're trying to find the perimeter of a quadrant, it has this arc whose length is pi r by 2. It has a line segment whose length is r. It has another line segment whose length is r, which is r. Yeah, so the perimeter of quadrant is equal to, what are the three things that make the boundary of the quadrant? There is one line segment like this, there's another line segment like this, and there's an arc like this. What's the length of this line segment? R. What's the length of this line segment? R. What's the length of this arc? Pi r by 2. All put together, add all this. So it is r plus r. R plus r, yeah, correct. Plus pi r by 2. So it is 2r plus pi r by 2, or pi r by 2 plus 2r. 2r plus pi r by 2. Please handle pi r by 2 as half into pi r. Pi r by 2 is nothing but half into pi r. So you must be clear as to what, if you need to find only the length of this one or the length of this total thing. Okay, so the figure will tell you. So you should not blindly use a formula. If you see a quadrant, it's not that you should use this formula. If you see a semicircle, this formula. It's not like that. You should observe the figure. You must observe what makes the boundary of that figure. What are the line segments or what are the arcs that make the boundary of that figure? Adhoda lens eல்லாம் தனித்தனியா கண்டுபிடிச்சு add everything, that will give you the perimeter of that figure. So it's not a standard formula. If you see a quadrant, 2r plus pi r by 2. Because what do I mean by saying that? What I mean is, supposing you have a figure like this. Okay. It's a figure like this. Now this figure is a semicircle and a quadrant. So it's not that if I say find the perimeter of this figure, that this is going to be the next question for you. I'm not going to, I'll just tell you, not in detail, but I'll just tell you. So you see a semicircle here and you see a quadrant here, right? So if you have to find the perimeter of this figure, okay, semicircle. What's the formula for semicircle? Pi r plus 2r. Okay, and then what's the formula for quadrant? 2r plus pi r by 2. It's not like this. It's not like that. It's not like, if the question is find the perimeter of this figure, you're not going to look at the figure as, okay, there is one semicircle, there is one quadrant. For semicircle, this is the formula. For quadrant, there's a formula. Find and add both. That's all. It's not like that. Perimeter is the length of the boundary. What are the arcs or line segments that make the boundary of that shape? What are the different line segments or arcs involved in the boundary of that shape? Adoda length eல்லாம் கண்டுபிடிக்கணும். It's not blindly taking the formula like this. Okay, now let's analyze the line segments and the arcs. Look at the board that go into making this figure or this shape. So don't say anything. There is this one. There is. So for perimeter, we start from a point and we come back to that point. We don't get into the figure. Perimeter, we never get into the figure. We always travel along the boundary of that figure. For perimeter, you should never get into the figure. You should always, you start from a point on the boundary, you travel along the boundary and you come back to the starting point. If you've done that, you have gone once around the boundary of the, whatever region given. So now say we start here. Okay, so you walk like this. You walk like this. The length of this line segment, whatever it is. Then the length of this arc. Then the length of this line segment. Then the length of this arc. That's all. Only these four things make the perimeter of the shape. It's not this formula plus this formula. It's not that how many line segments or how many arcs make the boundary of this shape. There is one line segment here. There's an arc here. Then there's a line segment here and an arc here. Arc, you understand, arc. Okay. So there are totally 2 arcs and 2 line segments. This will not come in perimeter calculation because you start here like this, then like this, then like this. This is the shape. This is the shape. You have to go only along the boundary. Don't get into the figure. This is the boundary. If you were to stick lace along the boundary, நீங்க எங்கெல்லாம் அந்த லேஸ் ஒட்டுவீங்க? இங்க ஒட்டுவீங்களா? உங்க டீச்சர் ஒரு ப்ராஜெக்ட் கொடுக்குறாங்க. இந்த ஷேப்பை கொடுத்துட்டு இதோட பவுண்டரியில லேஸ் ஒட்டிட்டு வரணும். பவுண்டரியில லேஸ் ஒட்டணும். அப்ப நீங்க இங்க ஒட்டுவீங்களா லேஸ? நோ, அது பவுண்டரி கிடையாது. பவுண்டரினா வெளியில மட்டும்தான். அது சுத்தி தான் வரணும். அதுதான் பெரிமீட்டர். இல்லைன்னா இப்படி புரிஞ்சுக்கோங்க. அந்த ஷேப் வச்சுட்டு பென்சிலால அந்த ஷேப்போட அவுட்லைன் போட்டா என்னெல்லாம் வரும்? அதுதான் பெரிமீட்டர். இப்ப இந்த ஷேப்போட கார்ட்போர்ட் கட்டிங் இருக்கு உங்கள்கிட்ட. இந்த ஷேப்போட கார்ட்போர்ட் கட்டிங் இருக்கு. அது ஒரு பேப்பர்ல வச்சுட்டு யூசிங் அ பென்சில் you draw the outline. You understand what I'm doing, right? So you just go along, you draw the outline of that shape. அப்ப என்ன வருவாங்க? அதுதான் பெரிமீட்டர். அப்ப நடுவுல இது வருமா? நீங்க அப்படி ட்ரேஸ் பண்றச்சே இது வராது இல்ல? அது வராது பெரிமீட்டர். So there's no doubt at all. See now, supposing you have to find the perimeter of this shape. Supposing find the perimeter of there's an equilateral triangle. This one is an equilateral triangle. Say the side is 14 centimeters. Okay. What's the perimeter of this figure? So perimeter is only the boundary. Only boundary. The length of this arc plus the length of this arc plus the length of this arc. அவ்வளவுதான். So again, இது அப்படியே இதோட பேப்பர் கட்டிங், அது கார்ட்போர்ட் கட்டிங் இருக்கு. ஒரு பேப்பர்ல வச்சு அப்படியே நீங்க when you draw the outline, what will you see? You will only see one arc, one arc, one arc. 3 arcs you'll see. That's all. நடுவுல இருக்க லைன் செக்மெண்ட்ஸ்லாம் வராது. அது பெரிமீட்டர் கிடையாது. அது பெரிமீட்டர்ல வராது. Got it? So what is this? This is a semicircle. This is a semicircle. This one is a semicircle. So what is the length of a semicircle? Not perimeter. Length. See here, this one. This is a semicircle. This is the length of a semicircle. Pi r. Pi r. So this one is pi r plus pi r plus pi r or 3 pi r. 3 pi r. Area of the shape will be area of the triangle plus the area of 3 semicircles. When it is area, you should whatever shapes you see, எல்லாமே தனித்தனியா கண்டுபிடிச்சு ஆட் பண்ணுவோம். இங்க என்னெல்லாம் இருக்கு? What are the different smaller shapes that go into making this composite shape? There's one equilateral triangle in the middle and 3 semicircles on each side. No, 1 semicircle on each side. So area of equilateral triangle plus the area of 3 semicircles is the area of this shape. But perimeter is not okay. ஒரு equilateral triangle இருக்கு, 3 semicircle இருக்கு. Equilateral triangle பெரிமீட்டர், 3 semicircle பெரிமீட்டர் எல்லாத்தையும் ஆட் பண்றது is not perimeter. Perimeter தனித்தனியா ஒரு ஆர்க்கு ஒரு லைன் செக்மெண்ட்க்கு தனித்தனியா கண்டுபிடிக்கணும் பெரிமீட்டர். Area you can do with the formula. Area of triangle plus the area of 3 semicircles. Got it? Okay, I'll just finish off with the formula. Then we can, start with the discussion of these answers. Hasini, any questions?
No, ma'am.
Akshita?
Mom?
Okay, so were you there when we started discussing the formulae related to circles?
Yes, mom.
Just let me know where when you joined, when we started this or this.
Mom, I have joined in the first, mom. When you started this, I have joined, mom.
Then I didn't notice you. Like when I saw the window, I saw only Hasini. Good, good. Okay. And what about these answers, Akshita? Finished answering these questions?
Mom, I have some doubt, mom, so I didn't complete it, mom.
Okay. Yeah, quickly make a note of all this. Yeah, make a note of everything you see here, no? Like along with the diagrams.
Mom?
Yes, Sakshita?
Mom, I have a doubt, mom.
Yeah.
Mom, is there any formula for 3/4 of a circle?
Yeah, good question. 3 by 4 into pi r square.
3 by 4 into pi r square.
Yeah. Thanks for asking. I'll include that now.
Okay.
Completed? I'll take it to the next slide. Yeah. Please take note everything you see on the screen. Don't miss anything. Yeah. Oh, yeah. At the Windows height. Hmm. I'll write that. Yeah. Right from the next slide. What? Look at your book. You're done. Look at your book. Completed all of you? It's called. I'll turn it on. Completed online children?
Yes, ma'am.
Okay. Okay, and what about perimeter for 3/4 of a circle? That's exactly what we discussed. I was just telling you, no? We took an example. Just a minute. Correct? This is 3/4 of a circle, right? You don't have to remember this as a formula. You can just apply it when you see the figure. So the perimeter will be the length of this line segment plus the length of this arc plus the length of this line segment plus the length of the semicircular arc. Correct? Let me, no, I'll just do it in a different way. 1 second. I'll just mark this red. So the length of this, no, just listen. And then I'm thickening it like this. Correct? So what's the length of this one? What's the length of this one? R. This one? Pi R by 2. This one? R. This one? Pi R. R. This is pi R by 2. This one is R and this is pi R. So perimeter of the shade, which is 3/4 of a circle. Yeah. Is equal to R plus R is 2R plus pi R plus pi R by 2. You don't have to remember this is for understanding. 2r plus pi r is not 2 pi r. You want to add pi r and pi r by 2, is it? You can add, yes. You can add. Plus, okay, plus. Akshita and Hasani, clear?
Yes, ma'am.
Yes, ma'am.
Okay, good. Okay. Next is about when do you, okay, we'll talk later. Fine. How do we find the area of a quadrilateral? How do we, what's the formula to find? 1 minute, let me just draw the figure first for you. Okay. So this is a quadrilateral, right? Okay, this polygon is called a quadrilateral because it's made up of 4 line segments. Okay, so the formula to find the area of this quadrilateral is half into D into H1 plus H2. Okay, let's understand why the formula, why this formula or how this formula is derived in a very simple way. Now connect one. Now this is a quadrilateral. Let's connect one of its diagonals. Any one of its diagonals. Okay, so let's connect this diagonal. Okay, yeah. Okay. Let's connect any one of the diagonals. Now ABC is a triangle. ADC is another triangle. Now AC is a diagonal. We'll draw altitudes to this diagonal. Okay, so the altitude to AC will come from the vertex B and from the vertex D. Step 1, join AC. Why? We divide the quadrilateral into 2 triangles. For both the triangles, we take AC as the base, the diagonal as the base. So we draw the respective altitudes. For both the triangles, we take AC as the base, so we draw the respective altitudes. So in the top triangle here, ABC, BM is the altitude on AC. Below, in triangle ADC, DN is the altitude on AC. So what is the area of quadrilateral? What is the area of quadrilateral? ABCD equal to, it is the area of triangle ABC plus area of triangle ADC. Am I right? Okay. Area of triangle is half into base into height. So I'm going to call this diagonal AC as D. And I'm going to call AM as H1 and DN as H2. I'm going to call the diagonal AC as D and the altitude BM as H1 and the altitude DN as H2. So area of triangle ABC is equal to half into base, that is D. half into, which is the base? AC is the base, into height, BM, plus half into base AC, other triangle ADC, same base AC, into altitude DN. So half into D into H1 plus half into D into H2. Now what's common? In both the brackets, we have half D common. Half D is common in both the brackets. So we'll take out half into D common into. So this half D is taken common. So write what is not outside, H1 plus. I'm not cancelling. I'm just telling you that this half and D is outside common. So write H2. So this is how we get the formula half D into H1 plus H2. Just adding the areas of the two triangles. Square units, right on? This is the formula to find the area of any quadrilateral. But you should have this information. You must know the length of one diagonal and the altitudes on this diagonal. You should have these three things. Only then you can use this formula. Am I clear, Harini? Yeah. Okay. All right. Next, parallelogram. So this is the parallelogram. Okay, when we say base, you can take any side of the parallelogram as the base. Okay, now see here. What is this?
Height.
This is the altitude. This is the altitude on the base DC. This is the, yeah, height of, yeah. AM is the altitude on the base DC. From the vertex A, from the vertex A. AM is the altitude on the base DC from the vertex A. AM, okay, I'm done. Now BN is also the altitude from the vertex B on the base DC produced. Now this length and this length will be the same. Supposing this is 6, this also will be 6 only. So you can take for the base DC, you can take AM as the altitude or BN as the altitude. BN is the altitude on the base produced. But AM is the altitude on the base inside the parallelogram. This altitude is outside the parallelogram. Supposing you produce this base, you produce the base DC. Okay, you produce, whenever you produce, it's in dotted lines. So you produce the base DC. Now from the vertex B, BN is an altitude. So to find the area of the parallelogram, the formula is area of parallelogram ABCD is equal to base into height square units. Okay, so if you have information about DC and BN, it is DC into BN. What is DC? The side. You cannot take DN. ABCD, which are the sides? AB, BC, CD, AD. These are the sides. Any one of these sides you can take as the base, not any line segment. ABCD is the parallelogram. AB, BC, CD, AD are the sides. Any one of the side you can take as the base, but you should have the corresponding altitude. So if you take DC as the base, you must have the altitude on DC, on it. So on it we have AM, on it we have BN. You can take any one of the altitudes. Am I clear? No, somewhat doubtful. No. So we know all this. Okay, so similarly, see here. Ashik from here it will fall. Now this is an altitude on which side? AP is an altitude on the side? BC or CB. Okay. So area of parallelogram is equal to base into corresponding altitude, square units. Okay. Write down base into height, square units. Area of parallelogram. Completed? Okay. All right. Next is rhombus. Correct. Yeah. So, like a parallelogram for a rhombus, also you can find the form. Like in a like for a parallelogram, you can also find the area for rhombus using the formula base into height. Okay, base into height. Or we have another special formula, half into product of diagonals. Yeah. That is whatever the information is given. If you're given details about the diagonals, you should use this formula. If you're given details about base and height, then this formula. If you have both the information, you find both the ways will give the same answer. So the standard formula is half into D1 into D2. Half into D1 into D2. Okay, so now I'll give you a question based on this formula and then we'll proceed. We still have, or let me finish. We have trapezium, that's all. Then rectangle, square, you know. Okay, then I'll put you with some questions. Done? Finished? Online children?
Yes, ma'am.
Yes, ma'am.
All right. No. Formula. Yeah, it is a trapezium. This is the formula in words. Area of trapezium is equal to half into sum of the parallel sides into distance between the parallel sides. Mhm. Area of trapezium is equal to half into sum of parallel sides into distance between them. So it is half into sum of the parallel sides, PQ plus SR, into distance between them. So distance between them is,
And the height.
yeah. You cannot take PS as the distance between them. PS is not the distance between them. So normally we call the parallel sides as A and B and the height as H. So it is half into A plus B into H square units. Half into,
A plus B into H.
have you marked A and B in the figure? A, B and H, please mark them in the figure. Finished? Okay. Yeah. Mhm. Okay. This is about a trapezium. Okay. What is, yeah. Think we're done with this. Okay. Then square, rectangle, height around that. Height also same formula. Supposing, okay,
Rhombus.
same form, yeah.
Quadrilateral and same.
Mhm.
Diagram.
Diagram? For a kite, if you're given the diagonal and the altitudes on the diagonal, you can use that formula. That quadrilateral formula is a general one. You can use it for any quadrilateral, provided you have that information. Now, for a rhombus or a rectangle, for a square, if you know the diagonal, the altitudes on that diagonal, you can use that formula. Area of kite is equal to half into d1 into d2 square units. You understand what d1 and d2 are? Diagonals. Half into product of diagonals. Hmm? Yeah. Okay. Fine. Time for some questions. What about these? We need to discuss this. Okay, one simple question, then we'll do questions based on these formula in the next class. But just because you wanted, let me see if you can recall this from 7th standard. Find the area. You're not asked to. Find the area of the rectangle ABCD. Quick. Yeah, you're right, Navneet. Do. Find the area of rectangle ABCD.
15 more steps, but easy.
Yeah, good.
The third formula is rectangle.
Find area of rectangle ABCD. Yeah, it's time. What's the answer? Show me a book, Navneet. Show me a book like this. Wrong.
Find a square.
Correct, you are right. What's the formula to find the area of a rectangle? What's the length? What's the breadth? You have to find the breadth. Is 20 the breadth? 20 is the length of the diagonal.
With the diagonal, with the
20 is not the breadth. Simply because we have two numbers, we cannot just multiply them. And have you written half into B into it? Show me your book. Half into B into H is the area of a rectangle. No? You find the area of a triangle?
Yeah.
Which triangle?
BD.
Okay, so half into base into height. What's the height? Perfect, very good. The multiplication, yes. Very good. Very good. Navneet, not Navneet, what's your name? Danvin has got the answer here. Akshita and Hasni. Akshita, Hasni.
Mom?
Completed this one?
No, mom, I'm about to complete it.
Okay.
1 minute, ma'am.
Okay. So we know the length of the rectangle. We do not know the breadth of the rectangle. So you need to find the breadth using Pythagoras theorem. So in right triangle BCD, how do we apply Pythagoras theorem?
A square plus B square is equal to B square.
Okay. So which is C? The hypotenuse. The hypotenuse is C. The hypotenuse is C. In right triangle BCD, A square plus B square is equal to C square. Okay. So that means what? BC squared, or you can write it. You can write using the sides.
BD square.
BC square is equal to BC square plus CD square is equal to BD square. You must square the hypotenuse and write it separately. Square the hypotenuse and write it separately. Square the other two sides and add. So what is BC? We don't know. BC square plus 16 square is equal to 20 square. So BC square is equal, BC square plus 256 is equal to 400. So BC square is equal to 400 minus 256. BC is equal to 144. BC square is equal, sorry.
BC is equal to square root of which is 12.
12.
Where it is 12. A square plus B square is equal. I did that.
Very good, very good. Pythagoras theorem, is it? Very good.
A square.
That's okay. You should square and write the hypotenuse separately. Hypotenuse is BD. BD square separately. Now area of rectangle. Area of rectangle is equal to L into B, which is DC. Okay, you don't have to write so much of, okay, DC into BC, which is 16 into 12, 192 centimeters square. Complete this. All right. Completed writing, all of you? Okay, I'll send the answers for these. We'll just discuss. Okay. So now for the first figure, listen to me. For the first figure, see area. Oh, okay. I'll talk about the perimeter first for all the figures. Okay. Now perimeter for this figure will be R plus R plus pi R by 2. R plus R plus pi R by 2. For this figure, okay, for this figure, for the second figure, R pi R, correct. For the second figure, the perimeter is R plus pi R. Okay, so first and similarly, the area for the first and second figure, 1 by 4 into pi R square, half into pi R square. 1 by 4 into pi R square, half into pi R square. The third one. The third one is a rectangle and a semicircle. So for the rectangle, you need to find the length and breadth. For the rectangle, you need to find the length and breadth. Okay, now this question, I should have marked 35. What have you taken 35 as? The length of the rectangle, huh? Okay, fine. That's better. Okay. I didn't mark it correctly. Okay, fine. From here to here. Okay. What's the length of the rectangle? 35. What's the breadth of the rectangle? 7. Okay, so what's the area of the rectangle? 35 into 7. Okay, now for the semicircle, what's the area? Half into pi R square. What is the R for the semicircle? What is the R?
3.5.
3.5. Why? Because this is 7. The diameter of the semicircle. See, this is a diameter. The semicircle is a diameter. This is the radius. This is the radius. This is the diameter. So diameter is 7. Radius will be 7 by 2. Take 7 by 2. Instead of 3.5, take 7 by 2. That is the breadth of the rectangle is the diameter of the semicircle. So diameter is 7, radius is 7 by 2. So you're the different shapes are rectangle and semicircle. For the rectangle, you know the length and breadth. And for the semicircle, you know the radius. You can answer any question. This is what you want, right? You want radius L and B. You have it. So area will be area of rectangle plus area of semicircle. What will be the perimeter? Perimeter will be 7 plus 35 plus 35 plus pi r. What are the four lines? What are the four things that make the boundary? 7, 35, 35, pi r. Add all this, that's the perimeter. You should not.
94.
Okay, I'll work the answer and I'll share it with you. You should not add this one. That will not come in perimeter calculations. All right? Yeah. In the next figure, it's a combination of a rectangle and two semicircles. Okay, it's a rectangle with two semicircular ends. So what's the length of the rectangle? Is 20 the length of the rectangle? 20 is not the length of the rectangle. So it is 20 is this one plus this one plus this one. 20 is what do you call this line segment?
Height.
R. It's the radius of the semicircle. It's a radius. See, this is a semicircle, right? This is the radius.
13.
Correct. This is R. This is R. And this is the length of the rectangle. This is the length of the rectangle. So this 20 is made up of R, and L. Wait, we're discussing now. Oh. See, I'm just showing you again. What is this? Akshita and Hasini, are you there, both of you?
Yes, ma'am. Yes, ma'am.
Very good. So see here. What is the length? What is the length from here to here? Radius. From here to here, length of the rectangle. And from here to here, radius. So this 20 is R plus L plus R. But what is R plus R? 2R. What is 2R? 7. No, see, you can see this, the diameter is 7. The diameter is 7. Radius is 3.5. So R is 3.5 plus length of the rectangle plus 3.5 is equal to 20. So 3.5, 3.5 is 7. 20 minus 7, 13. So length of the rectangle is 13. Okay. So the length of the rectangle is 13. The breadth of the rectangle is 7. See, if you're finding the area of the rectangle, you should use the length of the rectangle and the breadth of the rectangle, not some length. Okay, some length 20 is given. Come on, let's take that as length. This is not the length of the rectangle. So the length of the rectangle is 13 and the breadth is 7. 13 into 7 is the area of the rectangle. Then you must find the area of the two semicircles and add to find the area of the figure. Perimeter is the length of this arc plus the length of this arc plus the length of this line segment plus the length of this line segment. That's all. 4 things are there on the boundary. This shape has 2 line segments and 2 arcs on the boundary. This shape has 2 line segments and 2 arcs on the boundary. So what are the lengths of the 2 line segments? 13. 13. This is 13. This is 13. What is the length of this arc and this arc? Pi r. Pi r. R is 7/2. That is the perimeter. And for the 5th one, area will be area of the rectangle minus the area of the semicircle. Area will be area of the rectangle. If you just complete it like this. Okay. So there's some shape like this. How will you find the area of this? Supposing it's a paper cutout. How will you find the area of this paper cutout? அதாவது rectangle இருக்கு ஆனா இல்ல ஒரு semicircular region has been cut out. Actually இது ஃபுல்லா இருந்தா it's the area of the rectangle. பட் என்ன இல்ல அதுல அந்த ஏரியால என்ன இல்ல semicircular ஏரியா இல்ல என்ன இல்லையோ அதை எடுத்துறணும். When you join this, what is it? It's a rectangle. When you find the area of the rectangle, you're finding the area of this portion also, right? but that's not there. Meaning that's missing. That's not there. So find the area of the rectangle, and in the area of the rectangle, what area is missing? Semicircular area is not there. Okay, you have a rectangle with you. Okay, what's the area of the rectangle? 21 into 14. Now from that you're going to cut. You're cutting this portion, your semicircular portion. So what's the remaining area? Area of rectangle minus area of semicircle. So L into B you should find, and then half into area, half into pi r square. Half into pi r square. Pi r square by 2. Yeah, that will be the area. Area of rectangle minus area of semicircle is the area of the shape. Perimeter will be what makes the boundary? This, and this.
And
Arc alone you should find. Yeah. Okay, so what makes the boundary? Supposing you have to stick lace along this boundary. Supposing you have to stick lace. Perimeter is always understood like that. If you have to stick lace on this boundary, where all will you stick the lace? You will stick it here, or you will put the lace here, then here, then here. Suppose you stop. This is missing. No, inge otnuma ya lace. Boundary otnuna inge otnumalla. Appa in the length 14, in the length 21, in the length 14. Appro in the length mattu. What is this length? Pi r. Avladhan. Pi r. That's all. So what is the length of the tape you will need? 14 plus 21 plus 14 plus pi r. Length of the lace will be 14 plus 21 plus 14 plus pi r. Areas, area of rectangle minus area of semicircle. All right, I'll work the answers and I'll share it with you. So please practice after I share the answers. Now you've already tried by yourself. So once I share the answers, you can check your answers and my answers and, compare and understand if you've gone wrong. Okay. And see where you've gone wrong and learn it correctly. Okay. So that's about this one. I'll share the answers. Just one more minute. Okay. I just have to say one thing about this rhombus. We'll wind up the session with that. Okay. Now, area of rhombus. Shall I do this as a test? Why should I spend my energy now? The boys here are waiting for me to finish the class. Oh, sorry, one second. No. Why am I making this mistake again? I'm sorry, I'm just trying to. Yeah. Yeah. So what's the formula? For rhombus, we have two formulae, right? One is base into height, and the other is half d1 into d2. So we have to use half d1, d2, but we know the length of only one diagonal SQ, 24. The other diagonal PR, we don't know the length, but we know the hypotenuse PQ. If you take up this triangle POQ, how much is OQ? How much is SQ? How much is SQ? 24. So what is OQ? If SQ is 24, 12, OQ is 12, half of it, 12. How much is PQ? 37. How will you use Pythagoras theorem? I don't want A square, I want PO, OQ, PQ.
PQ square. PO plus OQ. PO square plus OQ square gives PQ square.
So PO we don't know. Plus OQ is 12 square is equal to
37 square.
Yeah, work this, all of you. See, I'll tell you, you can use A square minus B square. That will be interesting for you. See here. So PO square is equal to 37 square minus 12 square, right? So this is like A square minus B square. A plus B into A minus B. What is A plus B? 37 plus 12 into A minus B, 37 minus 12. So PO square is equal to, what is it, 37 plus 12?
49.
49 into 25. So PO will be equal to, look at the both, P square root of 49 into 25. So what's the square root of 49? 7. And 25 is 5. So 35. PO is 35 centimeter. 35. No, PO is square root of, no. So PO only it is, not PO square. Yeah, okay, yeah. PO square is 35 square, so PO is 35. So if PO is 35, how much is PR?
PR is 70. I'm so pretty 70.
PR is equal to 2 into PO.
Half into 70 into 24. Half into 24 into 70. 168. 1680.
Okay.
Half 840 down. My answer is 840. 840. Easy. Very easy. Time 3 o'clock. Exactly that 3 o'clock. Now, not I should start learning everything. If you want to, if it's 3:30, it's 3:30.
Okay, I'll just share this image on WhatsApp. I'll share all the images on WhatsApp. You can complete this at home. Your parents must be waiting. It's time. All right, children. So that's it for today's session. Thank you so much, online children. You may leave the call.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
See you.